So today we're going to review 3.4, 5.1, and a little bit of the first part of 5.2, and then we're going to finish up 5.2 and get most of the way through 5.3. Probably not all the way. At the break, if you have any questions about Exam 1, feel free to ask me then, and I'll answer them, because there's probably a lot of questions people have about how do I do this, or how do I solve that one, and we can go through those then. You have Connect Math 3.3, 3.4 due tonight. And then Thursday you have 5.1, 5.2, and also Project Lab Part 3 is due on Thursday. You can turn it in late for full credit next Tuesday. And if you are not sure how to do it, we went over it for we spent 23 minutes going over it last class, so I don't really want to do that again. It's not an effective use of time. However, just as a reminder, they are all here on YouTube. So if you go to, I sent you all a link to YouTube somewhere here. On last February 21st, last Friday I think, I sent you all a link to it. So you should all be able to click on that link. I think it said, actually, in your Canvas email, it said Project Part 3. So in your Canvas email, Project Part 3, you should be able to find that email I sent you last Thursday, click on it, and it'll give you the link to the project. And if you want to see other stuff, you can click on my name down here. You might have to subscribe to me. But then you can go to my playlists, and every one of my playlists is a different lecture, except for the projects. The project is like the little clips from each of those, from each lecture that pertain to the project is in that one. But otherwise, they're all the different lectures are all there. And this one, you can see all the different project parts. I've kind of pulled those parts out. This one, the first maybe minute or so might be, first 45 seconds or so might be the agenda, but then it goes right to the project itself. Okay, so look there if you want to kind of look back through how we did it in class to kind of refresh your memories on how to do some of the specific things. There's two versions. One is the Sheets version if you're using Google Sheets. That'd be the evening one, and it says on there Project 3 Google Sheets version, or it'll say 3.3 Night Part 1 and Project 3 Excel version. So you guys have the Excel version. So click on the one you want depending on what you're using. Okay. Where am I? Here. So let's jump right into stuff. Again, remember the z value. It's the number of standard deviations and a particular x value is away from the mean. How do you find it? You take your value, whatever value you're trying to find the z-score for, subtract the mean, divide by the standard deviation. For a sample, it'll be like this. Your z-score is equal to x bar is x minus x bar divided by s. That's for a sample. Also remember that sometimes it helps to think of standard deviations, because people have a hard time with what a standard deviation is, and z-scores. So think of z-scores as how many standard deviations, how many car lengths. If you think of a standard deviation like a car length, you can think of it as how many car lengths is one thing from the other one. So here, how many car lengths is it away from the mean? Might give you a little better sense of it, right? Because you're all familiar with car lengths. So you take something that's familiar to you, and if you apply the novel concept to it, it'll make your brain, your working memory will be able to grasp it a little bit better. Quiz problem number 5. Talk to your neighbors and make sure, say what you got and see what they got and confirm. 15 seconds, go. Yes,
This tool represents the number of standard deviations of values of these
You have to say how many numbers, because that's not going to apply, it's only how many standard deviations. All right, so everybody should be, a z-code represents the number
Of standard deviations, a value is above or below the mean.
standard deviations, yep, a value is, or a number is, either one, is above or below the mean. Okay, so we're going to say it together quickly, starting from A, z-score. Ready? 1, 2, 3.
A z-score represents
the number of standard deviations. A value is above or below the mean. You need to have these key things. Z-score, the number of, or how many standard deviations. That's important. The number of what? Number of standard deviations. A value. What is above or below the mean? A value is. Or you could say a number, that'd be okay. But then you got number twice. Away from or above or below. And you better say the mean. Above or below what? The mean. Those 5 things are all critical. So you could say how many standard deviations a number is away from the mean. That's okay too. But mean is really not really bare. And standard deviation, those 2 things are not, there is no other word for them. Right? So how many standard deviations a number is away from the mean, that's fine too. But it has to be, those 5 things need to be there in some form or the other. And standard deviation and mean have no other forms that are acceptable. Just those 2. Everybody all on board with that part? Okay. Don't forget, every problem will have a different standard deviation. Kind of think of it like a different car length, right? If your data is really spread apart, the standard deviations are going to be really large. If your data is all squished together, the standard deviations are going to be really small. The standard deviation is kind of roughly on average, how far are most of the values away from the mean. It's kind of a measure of that to some degree. Q1, Q2, Q3. Do you guys remember those? So first you put your data perfectly in order, and then you split it perfectly in half. The lower half and the upper half. You find the median of the lower half, that's your Q1. You find the median of the upper half, that's your Q3. And the median of all of it, the whole thing, that's your Q2 or your median. The median of all of it is the same thing as Q2. Yes?
Yes, but what do you do if you have an odd number of numbers? What do you do for Q1 and Q3? That's confusing me.
Right. Okay, so let's talk about that for a minute. First of all, how do you find the median? You put your data in order. The one in the middle, smack dab in the middle, is your median. If there are 2 that are tied for the middle, because it's an even number, then you average them. Now, when you split your data perfectly in half, if it's not perfectly in half because you have an odd number, you have this 1 sticking out there, then you can't split that guy in half. You have to ignore him and find the half. The half would be ignoring him, the lower half, and the upper half. So you would ignore him altogether. And then you find the median of the lower half and the median of the upper half. Did that explain what?
So no matter if it's an even or odd number, you're going to have to do some averages. Is that?
You may not.
Well, if it's.
Yeah, you'll have to do an average somewhere.
Right, okay.
Yeah, you'll have to have at least one average. Either your median will be an average or, yeah. Actually, that's not true. It's possible to not be. If you had an odd number, if you had 7 items.
Yeah. You'd have 1 in the center, 3
And then you find the middle.
and then the middle.
Yeah, so it's possible. So again, the 5-number summary is the min, Q1, Q2, Q3, and the max. Right, so those 5 items. Do you guys want me to do a quick sample of the 5-number summary? Okay, so here's the first example. You have your data, you put it in order. And then you split it perfectly in half, if possible. Then I need to find my Q1. So I took my lower half. There is an even number of items there. These two are tied for the middle. I have to average them. So I average them and I get 24.5. That's my Q1. These two, again, there's an even number. So there's two that are tied for the middle. I have to average them. And I get 65. That's my Q3. And then here, look at this. I got to average all over the place. There's two that are tied for the very middle. So I have to average them too. 39.5. That's my Q2. Everybody follow that? The min and max are easy. Those are the first and the last one. That's pretty straightforward. Here's another way it could go, which is that one that Sterling was talking about before. I arrange my data in order. I can't split it perfectly in half because there's one, it's an odd number. So I have to ignore him and split it perfectly in half, ignoring him, because I can't split him in half. Then I find the median of the lower half, that guy, median of the upper half, that guy, and median of the whole thing, that one. So this is my Q1 and Q3, and there's my Q2, or my median. So it's possible to not have to average anything. It's unusual. It has to be exactly set up like this.
It's every other odd number of numbers, like 7 words is also less
Yeah.
than 15.
Right. It's when you have an odd number, and each kind of half also has an odd number. Yeah. So you're right. It would be every four numbers. Mhm. So here's your problem. So first you have to put it in order, right? So 3, 16, 17, yep. 24, 24. Good. Can I split it perfectly in half?
Yes.
Yes. Lower half, upper half. I really encourage you to box your stuff or underline your box, some way so that you can tell. It's easier to wrap your head around it than when you have that. Right? Now I need to find the median of the lower half. There's just one number. It's easy. Right? There's only one in the middle, the very middle. Yep. So this is my Q1, and this is my Q3. Now, Q2 is a little bit harder, my median, because these two are tied for the middle, so I have to average them, and then that's my Q2. Great. Everybody all right with that part? The next one, I put in order for you, because I didn't want to waste time. Can you split this one perfectly in half? No, so you have to take the lower half and the upper half, ignoring the center. So here, then we take a look at these guys, and oh look, these two are tied for the center, I have to average them. 33, that's my Q1. These two are tied for the center, I have to average them. 62, that's my Q3. The quartiles could be halves. If I average an even and odd number, I'll get like something and a half, like 31 and a half. That's possible. Just so you guys are aware. Oh, we had that in the example. Do you guys remember that?
Yeah.
Okay. And then here is my Q2, and my min, and my max. So my 5-number summary is going to be 2, 33, 38, 62, 70. Questions? You guys need 15 seconds with your neighbors? Okay. And remember, they could be like, sometimes when you find the median, if they're if one's even, one's odd, you could end up with a half. That's possible. Right? This is also like these two, you average them, you could get a half. That sometimes happens. Okay. Box plots. Carl, go ahead.
A box plot or box whisker diagram is a graph of a data set that consists of a line extending from the minimum value to the maximum value. And a box of lines drawn at the first quartile, Q1, the median, and then the third quartile for Q3.
Good. So in other words, you're going to draw it through wherever your Q1 is, wherever your Q3 is, wherever your Q2 is, and then you're going to draw a box through them and then out to your min and max, wherever they are. So So here's your quiz problem number 1. So remember, box plots are pretty darn easy. They're going to be one of the easiest things we study these chapters. So it's going to be a really easy 3 points on the exam. The thing is, the key to making it correct is to put your number line along the bottom. And it should go ideally by tens, right? 10s or 20s. So I might, or maybe 5s, doesn't matter, but by some fixed number. So here our minimum is 2 or our maximum 70.
Yes.
Don't worry about the rest of the data. You have to go from 0 to 70. That's all you have to worry about. So 0, 10, 20, 30, 40, 50, oops, 60. See how I ran out of space? And I'd have to like scrunch to the page. You don't want to do that. Because then you have to kind of do this, and then you're kind of not, it's not, do you guys understand, it's not accurate?
Not scale.
So yeah, so maybe maybe hedge it a little bit and go, even if it's too small, that's okay. Like here if you did this, 0, 10, 20, 30, 40, 50, 60, 70, that's better than, and losing a space is better than running out of space. Because you definitely want to do this, 10, 20, 30, 40, 50, 60, 70, that's trouble. Can everyone see that? I'm going to totally mark you off if you do that. Okay. So let's go and take a look at this. 10, 20, 30, 40, 50, 60, 70. Oops, that's not right. 50, 60, 70, there we go. All right, so then what were your numbers? They were 2, 30, 33, 32, 30, 33, 38, 62, and 70. So it should look something like this through the Q1 and Q3 and the median, and then out to the whiskers.
Will we get marked down if we're on the scale?
Yes,
Oh.
that's how you lose your 3 points. Right? It should be like long here, short there, longish there, and kind of shortish there, right?
Okay.
Should be. That's the whole point of this graph. If you did a histogram and said your frequencies were like and said this is 2, this is 7, this is 3, this is 1, this is 8, would that be wrong?
Yeah.
Adam,
Yes.
right? That doesn't give you useful information. Right? The histogram you should see visually, the taller one should be taller. Right? And so that's the thing. It's got to be the whole point of this is to give yourself so people can look at it right away and get information about it that's useful.
Okay.
So that's why if you do this, for sure. Two, 33, right?
That's pretty much right. I
38, 62, 70. This is going to totally be, that's how you lose your 3 points.
think.
Because otherwise, that's just a 5-number summary. You've just written the numbers. They have no meaning whatsoever. The picture has no meaning whatsoever. Okay. Outliers. Jocelyn, go ahead.
An outlier is a value that lies very far away from the vast majority of other values in the data set. An outlier can have a dramatic effect on the meaning of considered deviation. A base value is less than 2 minus 1.5
What?
IQR, or greater than 2.3 plus 1.5 IQR can be considered an outlier.
Perfect. What does IQI stand for? Interquartile range. Interquartile range. How do you find an IQR?
Q3 minus Q.
Yep, Q3 minus Q1. So, what's an outlier? Okay, so here's my line here. Here's where my Q1 is. Here's where my Q3 is. So that means that this space from here to here, oops, that's my interquartile range, right? This is on a number line. This is my Q1, that's my Q3. This is my interquartile range. If I take this and go 1.5 this way, and I take this and I go from here 1.5 this way, then those are my kind of my boundaries for outliers. So if I were to go 1, it's not quite 1, sorry. Whoops. What's up with this? Stop. 1.5 that direction. 1.5 that direction. Then from here, well, maybe not quite there, sorry. I'm drawing bad lines. So this area over here, and this area over here, those would be outlier territories. Does that kind of make more sense? Here's my Q1, Q3. This is interquartile range. If I go 1.5 of them this way, and then from here I go 1.5 of them this way, then anything beyond here is an outlier. Anything beyond here is an outlier. That's outlier land. Anything in here, is not an outlier. It might be unusual, but it wouldn't be an outlier. Right? There's a possibility like these might be unusual, but not an outlier. This will come up. You will have to calculate and find those boundaries on your project 5, part 5. I'll come up there. Derek, go ahead.
The discrete probability distribution consists of values of the random variable. Assume corresponding probability values. The sum of probabilities of all events in the sample space add up to each probability between 0 and 1.
Inclusively, yep. So discrete probability distribution, it's all the possibilities that a random variable can assume. And that's it's your sample space, right? Every possible outcome, you list it, and then you list their probabilities. All these probabilities had darn well better add up to what? 1 or 100%. Also, every probability should be between 1 and what? 0 and 1. 0% and 100%, always. Expectation. So the expected value or expectation, why am I reading this? Haley, go ahead and read.
The expected value or expectation of a discrete random variable is the mean of probability distribution. Right?
Yeah, we'll do that in a couple minutes actually first. So the expected value of x, this is how to write the expected value of x, guys. It is the mean. What do you expect to get? You expect to get the mean. You do something over and over and again a whole bunch of times, you average all those outcomes, you expect to get the mean on average. How do you find the mean or the expected value? Take every x value, multiply by its probability. It's a weighted mean. Take every x value, multiply by its weight, its probability, and then you add those up. And then you divide by the sum of the probabilities, but all probabilities should always add up to what? 1. So you should divide by 1 so you can ignore the dividing by part. It's always going to be dividing by 1. So you take every x value, every outcome, multiply by its probability, add those up. Let's take a look. Here's what I mean. This is a sample I gave you guys last class, right? Remember, you go to grandma's house. Every time you go to grandma's house, at the end, she offers you 3 envelopes. One has $1 in it, one has $2 in it, one has $3 in it. And you get to randomly pick one and take it home. Next time you come, she has the same 3 envelopes. She has $1 in one, $2 in the other, $3 in the other one. On average, how much money are you going to make going to grandma's? $2. Because for every time you draw $1, you'll have another time you draw $3, and those will average to $2. And then if you draw $2, that is $2. So that kind of works out. This is it formally. You take every possibility, 1, multiply by its probability, 1/3, plus $2 times 1/3, plus $3 times 1/3. 1 times 1/3 is 1/3, 2 times 1/3 is 2/3, 3 times 1/3 is 1. Add them up, and you get 2. So multiply every x value by its probability. And then you add those all up. So do you guys need just another 2 minutes to finish up lab problem 4, quiz problem 4? Yes, no? Quick note. So a second ago I had the x's were here and the probabilities were beneath them. It can also go this way. X is here and the probabilities to the side like this. You can see it either way. These are probability distribution tables. We are going to be working with 4 types of probability distributions. This is the first one where I just give it to you and say, here's the table. There you go. The other ones we're going to be working with are binomial, normal, and uniform. You might have to compute some of those on your own. But this one, the probability distribution table, this is the first one, and it's just, we give you the table, there you have it. It's called a discrete probability distribution. Boom. Here's the data. Here's the numbers. Numbers, probabilities, it's all there. Okay, so you guys, every x value, its probability, find the expected value and the mean.